Today we're going to talk about perpendicular lines, okay? Perpendicular lines. First, I'm going to start with the definition of perpendicular lines. Can somebody guess what it might be? Yes, sir?
Two lines intersecting that creates 90 degrees.
Yes, two lines that intersect that creates 90, exactly. So, not exactly, but something like that. Okay, so you're right. So here is a definition of perpendicular. Yes, no, not the whole thing, just right here. Just definition. Just a definition. Yeah. Right here. Two lines that intersect to form right angles. And exactly what you said, but they said it a little bit differently, but that's fine. So that's the definition. Write it down. This is important. Oh, wait. Okay, so let me ask you this. If two lines intersect, okay? Imagine in your mind two lines intersecting. Yeah, you don't have to close your eyes. But imagine and I told you one of the angle is 90. What can you tell me about the rest of the angles? Everybody? Oh, 90. We sort of did this example like back when. I don't know when. It says page 21 we did it. Okay? So because we know that if two lines intersect and if one of the angle is 90 degrees, the whole thing is 90. Would you not agree? All the angles are 90. So because we know this, we could actually use this definition in two ways. Okay, so this is something you should know. So how do we use this definition? One of the way is this way. Write this down and draw the picture. Oh, I'm sorry. Draw the picture. So so let me move this up. So here, the definition of perpendicular lines can be used in two ways shown below. And what are the two ways? Here's our first way, is that if JK, as you can see on the right side, if line JK is perpendicular to line MN, written in, you see the symbol right here, upside down T. What do you think that represents? Yeah, perpendicular. Good. Sorry. Then each of the number angle, you see the number angle 1, 2, 3, 4. Guess what? They're all 90 degrees. Yeah, I'm saying they're already perpendicular. If you know that the two lines are perpendicular, then of course all these angles that those two lines create are 90. Okay? So that's one of the ways of using the definition. Okay? So write it down. Oh, wait. Okay, so this comes from the definition of what? Perpendicular line. So in other words, let's say you're doing your homework, hint, or on the test, okay, and I told you that two lines are perpendicular. What can you conclude from the definition of perpendicular lines? Nicole? All those four angles are 90 degrees. Does that make sense? And it's because of what again? Definition of perpendicular. Okay. Hey, you guys remember back when we were talking about biconditionals? Yeah. If you have definitions, we could always use definition as what? Biconditionals. You guys remember that? When you have definition, you could write definition as a conditional statement. And remember, after you write that conditional statement, right, and you write its converse, it is still going to be true. So we could write every time you have a definition, you could always write definition as a biconditional, right? The statement will be true, right? And the converse will be true. You guys remember that? So that's why they say the definition of perpendicular line can be used in two ways. One of the ways is this. Can somebody guess what the second way might be? Knowing that definition could be written as its converse and it will still be true. One person, two, three. You know what I'm talking about? Because definitions, right? If you were to rewrite definition as a conditional statement, it'll be true, right? But if you write its converse, it'll still be true because it's definition. Because all definitions can be written as a biconditional, right? So knowing that, is there a way to reuse this as a condition, as a converse? And this is how it's going to be used. John?
Two lines intersect and the angles are 90 degrees and they're perpendicular.
Very good. And they actually go a little further than that. They just say this. If any one of the angles is a right angle, they don't even say all four angles are 90. You know what I mean? Of course, if two lines intersect. If any one of the angles, number on the right side here, is a 90 degrees right angle, then guess what? Two lines must be perpendicular. Does that make sense? So write that down. That's another way of using the definition of perpendicular lines. If you happen to have two lines intersecting and one of the angles is 90, guess what? You could assume then, or you could conclude then, what? The two lines are perpendicular. Exactly. Okay? So write that down. All right. So I wanted to talk about next then, if we could also, of course, two lines could be perpendicular. Do you think two segments could be perpendicular? Do you think it's possible? Yeah. Okay. So can somebody look at this picture? Which two segments are perpendicular? Andrew? Yeah, segment MN and JK, right? Could we? Okay. So this is what they're talking about here. You don't have to write this down. So it turns out segments could be perpendicular. Also, can rays be perpendicular? Yeah, as long as two rays have common endpoints, right? So let's say this intersection is O, like OM and OK will be perpendicular and so forth. So it's not, the word perpendicular isn't only for a line, it could be used for a segment and rays. Okay, so that's sort of common, that's sort of obvious. Okay. No, you don't have to write that. Just know that. Okay, any question? Are you all ready for the first theorem of the day? Yeah. All right, good. I like that attitude. Remember? Good attitude. Okay, so, yeah, there you go. If two lines are perpendicular, right, then they form congruent adjacent angles. It's our first theorem. And we're going to actually prove this in class. Actually, you will. Okay, but if two lines are perpendicular, then they form congruent adjacent angle is our first theorem. And it's sort of obvious, right? What does it sound like? Maybe nothing. Okay. Maybe you're just writing. Okay, let me wait. Does this sound like something that we just studied? Well, what does it sound like? Nothing. Bisector? Not quite. Anybody? Yeah. What does this theorem sound like? Doesn't this sound like it's saying the same thing as what we? Yvette, what do you think? Hold on, what did you say? Just put your hand up. She's not done. What do you think? Oh. Okay. Kevin?
Vertically.
No. Yeah.
Two lines intersect, they make one point.
What? What are you talking about? Yeah. Yeah, say it again. One person. Yeah, isn't it saying the same thing as what? Yeah, the definition of perpendicular lines. Doesn't it?
Wait, what's the definition?
Okay, wait, what's the definition? We just talked about this. You look at your notes. Doesn't this sound like the definition of perpendicular line?
Yes.
Do you think there is a difference? And do you think that's why they actually wrote it as a theorem?
Yes.
Yes. Okay, if there wasn't any difference, they wouldn't have given you another theorem. I want you to think about the difference. What is the difference then between the actual definition of the perpendicular lines versus this theorem? And we sort of did this last time too. There's always a little subtle difference here. Samantha, what do you think?
The definition talks about the numbering angles. The theorem talks about congruent adjacent.
Okay, they talk about number angles for the theorem, definition. But what about the number angles? They actually talk about, what do they tell you what those number angles are? They are 90 degrees. 90 degrees. Does this theorem tell you anything about them being 90 at all? No. Turns out we have two other theorems, okay, today. None of those theorems talks about perpendicular line being 90. Only time you want to say, you want to use, if you want to say that two perpendicular lines gives you 90 degrees angle, is what do you want to use if you want to say that?
Definition.
You want to use the definition, none of the theorems. Does that make sense? Are we clear with this? Yes? Okay, by the way, do you guys agree in terms of what this theorem is saying?
Yes.
You do?
Yeah.
What does it mean? Somebody tell me what this theorem is saying here. How about Tony? What is it saying?
Oh, two lines intersect. They're
Go ahead, Tony.
perpendicular angles angles that are one that's next to each other are equal.
Exactly. And it is so obvious to us. What we even know the measurement of these angles, don't we? We know they're 90. But is this what this theorem is saying? No, all it's saying is that there are what?
Equal.
They're congruent. Their measurement is equal. Does that make sense? Do you see the subtle difference between the definition and the theorem? Very good. Now take a look at the next theorem. If two lines form, oh sorry. If two lines form congruent adjacent angles, then the lines are perpendicular. So Esther, go ahead and write this down. And think about what the difference between this theorem, the second one, versus the first one is, okay? I'll wait. Everybody go ahead and think about it too. Not just Esther, but everyone. Think about it. Okay, so I know I asked Esther, but how about Grace? What do you think? What's the, huh? Oh, okay. Grace, look at the first theorem that we just talked about. Look at the second one. Do you see any sort of relationship between the first theorem and the second? They're converse. That's all I'm asking, right?
Oh.
So you know you don't have to really memorize the first one, right? The second one is just converse of the first statement. So exactly my point. Did you hear what he said, Yechan? Yechan is actually, you just read my mind. So what's the point? Why are we even? Aren't they the same thing? Why do we even write it again? First of all, Yechan, if you have a statement that is true, and you write its converse, is it necessarily true? No. So, not always. So, that's why I'm writing it. This time I'm telling you, the converse of this theorem is true.
Wait,
Yes.
so in a proof you write both of them down?
No. In a proof, you write the one that is, that is appropriate. And we're going to talk about that right now. Very good. You read my mind. Now, very good. You're all reading my mind. John, Young, did you have something to say? Okay, Young, what do you think about then? The question is then, when do you use what? Isn't that what you're asking, Austin? Right? Because they sound, or they look like they're sort of similar. Anybody know what the difference between these two theorems are? When do you use which theorem, in other words? So let's look at the first one. Like, let's say that you're doing some sort of proof. What do you have to have? What do you have to have in order to use the first theorem? I'm going to hide that second one. Well, let's not hide. Okay, let's look at the first one. What are you going to use? What do you have to have in order to use that first theorem in the steps? Nicholas? You have to given that the two lines are perpendicular. Look at your hypothesis. It says if two lines are perpendicular, then you could conclude, right? The adjacent angles are congruent. Does that make sense? That's the, because can I use this one if the two lines are perpendicular? No. When can you use the second one then? When do you think we're going to be using the second one here? Who haven't I called? I haven't called. How about Josh? Sorry?
They don't tell you that it's
When they don't tell you that they're kind of, but then they gotta tell you more than that. Just because two lines are not perpendicular doesn't mean, right? This second theorem works, right? You know what I mean? In other words, if they don't tell you that their lines are perpendicular, can you conclude that they're perpendicular? No, it doesn't make any sense. What do we need? Yechan, you actually.
You even have to say the two lines. No, they're congruent.
What are congruent? A little bit more.
Adjacent.
Okay. Good. Listen carefully. Okay, so let's say it doesn't have to be given. It could be part of your, like, as you're doing this deductive reasoning, as you're doing your proofs, right? Let's say that you, in your lines, it says you have congruent adjacent angles. Okay. Can I then conclude, using this theorem, that we have perpendicular lines? How many people say yes? Raise your hand. The question is, if on your proof, right, either it's given to you or you've sort of proved it as one of the statement, that you have, let's say that you have two congruent adjacent angles. Does this then, can you write afterwards then, oh, then they must be perpendicular, the two lines? Raise your hand if you think yes. How many people say no? One brave person. Two brave. Three, four. Amy, you are correct. That would be wrong if you say that. Yeah. Amy, which part have they left out or forgot to say? Right. Is it enough to just have two congruent adjacent angles? What else is needed? Amy?
Right angle.
You have to say louder. 2 lines. Guys. No, we only said 2 congruent adjacent angles. Okay, Amy is correct. You have to have not only 2 congruent adjacent angles, but you have to have 2 lines. For example, watch this. Listen. What if 2 angles are 30 degrees and 30 degrees? Aren't they? So let's say you imagine 2 adjacent angles that are 30 degrees right next to each other. Do they form perpendicular lines? Of course not. Do you see why I'm telling you to really, whenever you remember these terms, you have to really remember word by word? If you left out the lines, the word lines in here, so then you just remember this as if 2 congruent adjacent angles, if you have 2 congruent adjacent angles, then the lines are perpendicular. Would that be right? No. 2 adjacent angles, congruent adjacent angle does not give you 2 perpendicular lines. You have to have the lines, right? So the 2 lines form, right? When the 2 lines form congruent adjacent angle. I mean, this is sort of obvious. If the 2 lines form congruent adjacent angle, we know even what that angle measurement has to be. It's 90. It is so obvious to us. But does this theorem say anything about 90 degrees at all? No. But we know what they are, right? Do you understand the difference? Do you understand the subtle difference? So you have to, when you have 2 lines and then they form congruent adjacent angle, then they form perpendicular lines, okay? Then this is when you use this theorem. Do you see that? Are we good? Does this make sense? I want you to talk to your group, see if they get it. Go ahead, I'll give you time. Does this make sense? So any question about these 2 theorems, now that you talk with your group members? And no? Do you understand when to use which ones here? Okay, good. Now let's go on to then our last theorem of the day. And I want you to write this down, and I want you to draw this picture on the right side also, because that picture is going to help us to understand what this theorem is saying. It says if the exterior sides of 2 adjacent acute angles are perpendicular, okay, that's sort of long, but see if you can understand, then the angles are complementary. Even though it sounds sort of long, it's really saying something very simple and obvious. So go ahead and write this down, and as you write this down, draw the picture. I want you to think about what are these exterior sides that they're talking about in this picture. Go ahead. What are these exterior sides? I'll wait. Go ahead and write this down. So have you all thought of what the exterior sides of these angles are?
Yes.
Yes? Okay. Esther, what do you think? Can you give me one of the exterior sides that this theorem is talking about, first of all? Say it again. OA is correct. Isn't that one of the exterior side? Exterior means outside, right? What's the other exterior side then? Jonathan? OC is correct. What is this theorem saying? Can somebody explain what this theorem is saying here? Anybody on this side? Okay. Oh. It's like, you have a question. Go ahead. Oh, that's a good question. The question is, even if the exterior sides are perpendicular, don't you need an angle bisector in order for these angles to be complementary? The answer is not necessarily. They don't always. This ray OB does not have to bisect this angle every time for them to be complementary, right? Because this angle could be 10 degrees. This could be 80. Oh, okay. So. Right here, this angle right here, angle BOC could be 10 degrees, angle BOA could be 80 degrees. As long as they add up to 90, they're complementary. They don't have to be 45 degrees, right? Definition of complementary angle says, as long as they add up to 90, they're complementary. Not quite. I think you're missing something here. So first of all, do you remember the definition of complementary angles? What is the definition of complementary angle? 2 angles that add up to 90. If angle AOC is 90 degrees and you have a ray in between angle AOC, do you see how this angle, let's say this angle is x degrees, right? What's this angle measurement then? 90 minus x. What's 90 minus x plus x? 90, so they're always going to be complementary. Does that make sense?
Yeah, I mean, never mind.
Okay.
Get it? It's interesting.
Are you sure? Okay. Okay. So, what is this? What is this theorem saying then? We sort of talked about this already. 1, 2, 3 people see. 4. Somebody over here. Amen. What is this one saying? What is this theorem telling us?
It's saying that
Let's listen.
the two adjacent equals, say, axes, the exterior sides are perpendicular,
Right.
so they have to equal 90.
Exactly. That's basically what he's saying. Since angle AOC, OA, ray OA, and ray OC are perpendicular, guess what? Some of these two angles must be 90. They're complementary. That's all they're saying. Does that make sense? Any question? Okay. Does that make sense? Okay. Then we're going to actually prove our first theorem. By the way, in order to prove the first theorem, can I use the other theorem to prove it? No. Okay, you can't go forward. You can only use the one that was before it, not after. Does that make sense? So let's, yeah, question? Oh. Don't forget. Okay, so let's move. Here is our theorem that we just talked about. You don't have to write the whole thing. Can you write down, given though? I'm sorry, it didn't get scanned correctly. It should be L perpendicular to N. So it's referring to this line L, and then it's referring to the line N. So given is that L and N are perpendicular. Can you prove that angle 1, 2, 3, 4 are congruent angles? Again, this is your what? First theorem, right? Question? Yeah, right, yeah. I want you to write given and prove and draw the picture. Just like how you do on your homework, right? Isn't this what you do on your homework too? If I ask you to, yeah, that's copying the question and drawing, right? Go ahead. And as a matter of fact, I want you to actually prove it yourself. You may, of course, help each other out as a group. Okay, go ahead. I'll give you time. See if you can prove this. Go ahead, guys. So as I walked around, I had some good conversation. Some people say, wait a minute. Can we just use that theorem that says if two lines are perpendicular, then all the angles are congruent? Why not?
Because it comes after.
No.
That's what we're trying to prove.
That's what we're trying to prove. Okay, it's not.
My
Yeah.
bad.
Yeah, that's what we're trying to prove. So you can't use that theorem that says if two lines are perpendicular, then all the angles are congruent, because that's what we're trying to prove. Okay, so that's out of. So at least, but also here's. Let's. Okay, first of all, everyone should have written the first line. Yes? Did you all write the first line? Okay. Yeah? Did you write this? And what's the reason? I'm sorry. What's the reason? Given. Okay. So that's given. Now, some of you said then this. Mr. Wong, can we just say then, by definition of, two lines that are perpendicular lines, aren't they all congruent?
Can't do that, right?
Why not? Isn't that what the definition say? No, it doesn't. Definition does not say all of them are congruent. What do they say? That they're 90. Is that different? Well, in our mind, it's not really. If they're all 90, of course they're all congruent, right? But as a deductive reasoning, as a proof, guess what? We have to actually say it, even though in our head it just totally makes sense. So how do we do that? So as a second step, anybody know what to do as a second step? Oh, a lot of you? Okay. Somebody that have. Okay, how about Pon One? What do you think?
Angle 1, angle 2, angle 3, angle 4
Are 90 degrees, and what's the reason, guys? Definition of perpendicular line is correct. Okay. The reason why all these angles, angle 1, 2, 3, 4 are 90 is because of definition of what? Perpendicular lines. Definition of perpendicular. Nicholas, did you have something to say, or you have a question? Oh, you know the next step? Okay, hold on. And like I said before, many times, when you solve equations, there are many ways of solving equations, right? So just like that, when you do proofs, there are many ways of doing this. But turns out, you could actually be done with this proof after just one more step. Okay? And in other words, if you should all have the first line and the last line, okay? At least for the statement. What are you going to write for the statement for the last one? If I could finish in 3 lines, you're going to say, yeah.
Angle 1 is congruent
Or just, yeah, angle 1, 2, 3, 4 are congruent. Exactly. Okay, so I'm telling you, I'm claiming to you that you could finish this with this one more line. Can somebody tell me the reason why? If you could do this. Okay, 1, 2, 3, 4, 5, 6, 7. Nicole, what do you think?
Wait, never mind.
Oh, okay. Jason, what do you think?
Substitution.
Can you substitute for congruence, Jason?
Definition of congruence.
Say it again.
Definition of congruence.
Almost. Definition of congruence, almost, but it's similar to that. It's a little bit more specifically, it is definition of, yes, congruent angles is correct. I don't have the answer here. But it's because of definition of congruent angle, right? Because look, all the angles are 90 degrees. What does definition of congruent angle say? Angles are congruent if they have the same measurement. Does that make sense? So with that, you could finish this proof in 3 steps. Any question? Does this make sense? Do you see the subtle difference between the definition of perpendicular lines versus one of these theorems? Any question? Are we good? The last step is what? Definition of congruent angles, okay? Because that's what we just said. All the angles are 90, therefore they're all congruent. Okay. Any questions? Yes, sir.
Is this it?
Yeah, that's it for today. Any questions? All right. Yeah. Yeah. Any questions?
No.
Good. All right.